First, let us define what is a number. A number is an abstract idea addressing the question how many. Why a numeral is the symbol that we use to represent the number. A numeration system consists of a set of basic numerals and rules for combining them to represent numbers. The numerals we use daily are called the Hindu Arabic numerals because it was invented in India and the Arabs brought to Europe. The Hindu Arabic numeration system let us write any number using just 10 symbols. These symbols are called digits. The digits are, of course, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Since the values of the digits are changing according with the position of the digits in a numeral, the system is called a positional value system. In a Hindu Arabic numeral, the place value of the first digit on the right is 1. The place value of the second digit from the right is 10. The place value of the third digit from the right is 100, and so on. The positional value in the Hindu Arabic system are based on powers of 10. If we write the number 7,823 in expanded form, that would be 7 times 10 to the third, 8 times 10 to the second, 2 times 10 to the first power, and 3 times 10 to the 0. So 3, that is the digit to the right, its place value would be 1. 2, that is the second digit from the right, its place value would be 10. That was what we mentioned before. Now, there is a very interesting question here. Is the numeration system used by the computers to process information a base 10 system? The answer is no. The system that is used in computers is mostly a base 2 system or binary system. Computers also use the octal, that means base 8, and the hexadecimal, that is base 16 systems. So these other two systems, the octal and hexadecimal, are also used in computer sciences. Now we want to explain the binary system. The advantage of the binary system is its simplicity. In binary system, instead of using digits from 0 to 9, we use just the digits 0 and 1. A computer device can be created with a series of switches that are going to alternate between on position, where let pass an electric pulse, and the off position that will be interrupting, the electric pulse. When the switch is on, represents a 1. When the switch is off, represents a 0. How can I write 73 in base 2 system? If we want to write the number 73 in base 2 system, the first would be to list the place values in base 2. Those are 2 to the 0, that is 1, 2 to the 1, that is 2, 2 to the second, that is 4, 2 to the third power, that is 8, 2 to the 4, that is 16, 2 to the fifth, that is 32, 2 to the sixth, that is 64, 2 to the 7, that is 128. Second, we are taking the place values lower than 73, in this case starting with 64, and we use division to find how many of these place values are in 73. So we divide 73 by 64, and we find that we have one group of 64 in 73. The remainder of the division is 9, so we divide 9 by the next place value, that is 32. Of course, 32 is greater than 9, so 0 would be the number of groups of 32 that are in 73. Later, we divide, again, the same remainder 9 by 16. 16 is greater than 9, so have 0 groups. The remainder is again now 9, and then we divide 9 by 8. And when we divide 9 by 8, we have that 8 goes once into 9. So subtracting 8 from 9, we get remainder 1. We divide the remainder 1 now by 4, that is the next place value. 4 goes 0 times into 1, so the remainder is again 1. Later we divide 1 by 2, 2 goes 0 times into 1, so we get remainder 1. And finally we divide 1 by 1, and 1 goes once into 1, so we get at the end remainder 0. The quotients of each of the divisions are going to be now the numbers or the digits that we're going to use, to represent our base 2 numeral. So we can say that now 73 in base 2 would be 1001,001 base 2. We have to be careful. We cannot read, the number 1001,001 like a 1,000,001. That would be wrong. So we have to go digit by digit. 1001,001 base 2. This is the representation of 73 in base 2. Number 73, that is equal to 1001,001 base 2, is the binary code on, off, off, on, off, off, on. So that is going to be the combination of the different switches. Can I represent words using the binary system? Yes. Each letter is represented by a number using the ASCII code. The ASCII code is just the American Standard Code for Information Interchange that was designed in the 60s as a standard character set for computers and other electronic devices. If we want to write the word love, we're going to have the word love in the decimal system, the L, using the ASCII code, is represented by the number 76, the L capital. The O capital is the number 79, the B capital is the number 86, the E capital is the number 69. If you convert 76 to binary, would be 01001100. To convert the 79 to binary, you get 01001111. If you convert the 86, you get 01010110. And you convert the 69 to binary, you get 01000101. So in the bottom row, in the last row, you have the word love in the binary system. I hope that this mini lecture just be interesting for you, and we are just in the future presenting more mini lectures like this about very interesting topics of mathematics and science. Thank you.